So this video, we're going to talk about the derivative of sine and cosine functions. So here we have that the derivative of the sine function is the cosine function, and the derivative of the cosine function is the negative sine function. Now, can you figure out why? Can you use the definition of a limit as the difference quotient as delta x approaches 0 to prove this? I'm going to leave that for you as an exercise. So try it out and see if you can figure it out. In the meantime, we'll just use it and just understand that the derivative of sine is cosine, the derivative of cosine is negative sine. So let's try it. Y equals 2 sine x. Well, we know the 2 is just 2, right? Because remember, we can just pull the 2 out front because it's a constant times. So 2 times sine x, but the derivative would be cosine x. What about sine x over 2? Well, we can rewrite this as 1/2 sine x, right? So y prime would just be 1/2 cosine x because we're taking the derivative of sine as cosine. What about y equals x plus cosine x? Now this is the sum of two separate functions. So we take the derivative of x, which is just 1, plus the derivative of cosine, which is negative sine x. Last one here, y equals cosine minus pi over 3 sine. Well, this is a difference. So the derivative of cosine is negative sine minus pi over 3 times the sine, which is derivative of sine as cosine. So you have negative sine x minus pi over 3 cosine x. So if you have any questions about taking the derivative of a sine or a cosine, they're really basic. Shoot me an email or remind or ask a question in class. However, I'm going to throw this out here. Anybody who watches this video and brings me proof of this sine, we'll do proof of this one. Proof that the derivative of sine x equals cosine x by using the limit definition of a derivative, I'll give you 5 points on your next quiz.